Hi. In the last module I did the data path diagram and I started writing the Verilog description for the data path. So in this module what we will see is as a gray box, which means we know the connections but we still do not know the internal implementation of the various modules for inside the data path. So what I am going to do is I am going to give a description of the data path itself as though it is picking various modules and connecting them together. Just like what we did for the topmost design, I am going to do something very similar for the data path itself. So let us look at the picture. I have now named the wires. So I am going to call this wire T1 and this wire T2. This is TA in, TB in, this is TA out and TB out. This is register A and that is register B. This is a register called output. So we had all of these earlier. So let us go and write the descriptions for it. So I left it at this point in the last class. So let us see the picture. From the picture, the first thing that you need to do is the subtractor is supposed to take, one of the subtractors is supposed to take TA out as one of the inputs, TB out as the second input, and it is supposed to produce T1 as the output. So I will write a subtractor S1 which takes TA out as the first input, TB out as the second input, and it is supposed to produce T1 as the output. So that is the first subtractor. Then let us look at this, the second subtractor here. The second subtractor should be subtractor S2, which is supposed to take TB out as the first input, TA out as the second input, and it is supposed to produce T2 as the output. So we have taken care of connections that are coming into the subtractor and out of the subtractor. So again let us look at the picture. So now we are supposed to design the mux. So the mux is supposed to take T1 as the 0 line and in 1 as the 1 line and A select as the select, TA in is supposed to be the output. This mux is supposed to take T2 as the 0 line, T1 as the in2 line as the 1 line, and the select is B select and the output is TB in. So we need two muxes. So I am going to assume that muxes are given in this form. So in the select line, the output that is going to come from it and the two inputs that are supposed to be supplied to it. So I am going to assume that the mux, so I will call that mux M1. The first mux M1 is supposed to give an output. So the output is actually TA in. Okay. So we have the output which is TA in. I will give the select line which is A select. We have the A select. Then we have the two inputs. In this case it is supposed to be T1 and in 1. So T1 is the pin 1's input and in 1 is the, sorry, T1 is the pin 0's input and in 1 goes to the pin 1's input. Similarly we have mux M2. So again let us look at the picture, mux M2. This is supposed to give TB in as the output. So TB in as the output. Then we have at the 0 pin we have, so the select line is called B select, we have B select. At the 0 line we have T2 and at the 1 line we have in 2. So I will put T2 and in 2. So we have taken care of 4 different things here. We have taken care of the subtractors, we have taken care of the multiplexers. Now we need to take care of the registers. There are 3 registers, and for the register what I need is, so I know these are a bunch of flip flops, so they of course will take clock and reset as the set of inputs that you need. So these are 2 inputs that you will need for them, and besides that there is an input that is coming in, there is an output, and there is a load enable. So this load enable, if it is on, TA out is supposed to copy TA in. So that is the thing that we wanted. So when I described the Verilog description, when I did the data path design, I said we do not want the output changing in every cycle, we have to retain the values for one of them. When the GCD is running, either this will be kept constant or this will be kept constant till the next subtraction happens, right. So we needed the load signals. So, I will assume that all of these load signals and other things are there in a module called a register, and for this register what I am going to do is I will write the design description right now. So, I will assume that somebody is going to give me a design description for a register. So, I have register R1 which is supposed to take clock as an input because it is a sequential circuit, reset as another input. So, clock and reset are given, then it is supposed to take TA in as an input and the load enable as an input and give TA out as an output. So, I will write it in that order: TA in, A load and TA out. Similarly, register R2 will take clock, reset, it will take TB in as the input, B load as the load enable signal and TB out as the output. And finally, we will need a register which is for the output itself, right. So, there is this output register, we need a register for that. So, I am going to call that register R out, and R out takes clock, reset. The input to the register is actually TA out, the enable signal is actually coming from the external thing, this output enable is supposed to come from the controller. So, I am going to put that here, output enable, and the actual output is supposed to be driven to the output itself, which is this one, which is called out. So, I am going to put that, and this takes care of the registers. The only other thing that we need is a comparator. The comparator, so let us again look at the picture. So, I will call the comparator, let us say C1. So, this comparator is supposed to take two inputs, in1 and in2, and is supposed to give three outputs in this order. So, I am going to put that as three different things. So, the inputs that it is supposed to take are TA out and TB out. These are the two data inputs that it is supposed to take, and there are three outputs, namely A greater than B, A equal to B, and A less than B. This actually completes the design of the data path. So, what we have is, we know that the data path is supposed to contain two subtractors, three registers, and two muxes and one comparator, and we have already put in the design description that is required. So, again from a top level view, if you have this picture, all we have done is taken the picture that we have drawn and put that on the put that in the Verilog form. That is it. We still do not know how to, we have not written the description for a subtractor, for the multiplexer and so on, but that is okay, we do not need it right now. So, I am coming top down, and when I am coming top down, I have decided various things that I need. Now, as a design team, right, let us say I am going to build a design team to do a chip, I may actually tell one engineer to go and design a subtractor, one engineer to go and design a multiplexer and what not. So, usually these are very small things, you do not give them to different engineers, but just as an example, if I want different engineers to take up different portions, I can tell them, see, this is the design description that I need, functionality wise this is what I want, and these are supposed to be the inputs, these are supposed to be the outputs, go ahead and design. Once they are done, I can collect all of that back together, and already I have the design description which is supposed to put all of them together and connect them together. I will be ready to run the design. So, let us take one last look at the picture here. So, in this picture what we do not have so far is the names, right. So, I had different names earlier, now I will put the names in the picture itself. So, this subtractor I called S1, this subtractor I called S2, this multiplexer I called M1, this multiplexer I called M2, this register I called R1, this one I called R2, this one was called R out with a capital OUT, and this one comparator was called C1. So, these are the names that were given to the different modules, and these modules are instantiated right now in the Verilog description. These instantiations have to be written up, we do not have the design descriptions yet, we only have the instantiations at the data path. We now have to go and write what a subtractor is, what a multiplexer is, what a comparator is, and what a register is, and these are things that, so at least the multiplexer and register are things that you already know, So, I am going to show you how to write a subtractor and how to write a comparator. So, we will see that in the next module.